till now in our earlier. Okay. So basically, till now in our earlier classes, we used to calculate mean, median, and mode through those long formulas which we used to mug up and which we used to apply on, and then we used to calculate mean, median, mode. But now, as uh, in the later stages, when the numbers are very much and when the data is too big, it is not easy to calculate those mean, median, mode and those descriptive statistics part with the help of those formulas. You cannot apply manually. You can, but it will take a lot of time. And now, as you all know, that we have a shortage of time these days, so we don't apply for these manual calculations. So for those things, we have three basic tools which sir has already stated in the last discussion that we will use for calculating descriptive statistics and inferential statistics. The first tool is your Excel, which you already know. The other one is Minitab. And the third and the most advanced tool for calculating, most advanced software for using descriptive statistics and inferential statistics is SPSS, that is Statistical Package for Social Sciences. So we'll go one by one. We'll see how it is calculated in Excel. We'll see how it is calculated in voices repeated. Okay. Right.
Okay, now my voice clear. Hello. Hello. Okay. 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 So now, what I was saying that we'll see one by one that how the descriptive statistic is being calculated with the help of Excel, Minitab, and SPSS. We'll start with the Excel first. I'm taking a very simple numerical that is how to calculate arithmetic mean. Now in Excel also we have three different methods of calculating statistics. One, the simple formula function, that is average. You must have all used it before also. That is basic function in which we just uh, write the formula average, and then we select the numbers, and then based on that we get the answer. This is the basic formula which this is the basic method which we all have used once in our life. So this is one of the technique of calculating average. The other method of calculating arithmetic mean from using Excel is the insert function method. In this we'll just check the insert function, and this dialog box will appear, and from this select the category method. From there you have to select statistical function, and in that you'll select average. This is the same as the last average function which we have used, in which we have to select these values, and based on that we will get the desired result, that is 148.5. These two are the basic method of calculating average mean, simple mean in Excel. Now the third method for calculating the descriptive statistic using Excel is using the data toolbar. Okay, for that thing you have to add on the data tool pack in the Excel. From that you will get, just a minute, shift this thing. Now, for that, you just have to simply go to this data option, and there you will get this data analysis pack. In this data analysis tool, you have to select descriptive statistics. There you will get the option to use descriptive statistics. In after, if you select this descriptive statistic option, then you click OK, you have to input the range. There you have to insert those numbers for which you have to calculate your descriptive statistics part. And then you will select for summary statistics. Confidence level for mean, it is not required now. We'll discuss this in inferential statistics part. From now, for now only, you just have to select the summary statistics. When you select the summary statistics, you'll calculate. When you say okay, this will provide you the results of everything, that is mean, median, mode. As we can see that this data, it is a very simple data, so it doesn't have any mode. And this is the data, and we have calculated this descriptive statistics part from this descriptive analysis toolbar. Just a simple click and you will get the descriptive statistics for as long data as you will get. Even if your data is too big, just a single click and you will get the descriptive statistics part. This is what basic Excel function, how we use the descriptive statistics using Excel. The other software which sir has discussed is Minitab, and the next one is SPSS. We'll see the same example through Minitab now, how it is computed using Minitab. From the Excel, it is very easy. We have three methods. First, the average method will simply insert the average formula. The second method is insert function method, in which we simply insert the method, insert the we'll simply check the average function from the insert option. And the third is data analysis toolbar. This data analysis toolbar is by default not available on your Excel. You have to add on through the option button you have in your Excel. From there you can use this data analysis tool. This is an add-on. You just have to add on this descriptive statistics part, and by using that simple click you can get the descriptive statistics for n number of data. So this is for the Excel part. Now I'll switch to Minitab. Just hold on. Okay. This is your Minitab software. Minitab software is one of the advanced software for calculating statistics part. It is used for calculating, it is used for testing hypothesis, testing Z statistics, T statistics. The sir has already discussed in inferential statistics about the hypothesis testing. We'll see through number of examples how it is done. So basic Minitab, this is the basic interface of the Minitab. This is more like Excel. You have to enter the values here. This I have taken a small example, rainfall, and this is the 10 number data. We'll just simply see how to calculate mean for this data using Minitab. Now we just have to go to stat option. We'll get this stat option. There you have to select for basic statistics, and there you will display descriptive statistics option. When you select display descriptive statistics option, you will get to choose the variable for which you want to compute the mean. You just have to add that variable. Here the variable is the rainfall, so we'll just add rainfall here. and then we'll check the statistics part. Now, as you can see, there are a number of options which you can calculate. Now, if you want to calculate mean, you can check off that box, mean. If you want to calculate range, sir has already discussed in descriptive statistics part in measure of dispersion, that range, standard deviation, variance, they all are the component of your descriptive statistics part. So if you want to calculate anything, you don't have to hustle for those manual calculations. You just have to go for one click and you will get anything you want. For if this data is very small, you can calculate it by manually, but there, if the data, suppose the data would have been for around 2000, 3000 or 4000, it is very difficult to calculate manually for those data. So for that, just one single click, what you want, mean, you can calculate mean here, first quartile, median, third quartile, variance, standard deviation, anything you can calculate. Just have to use mini tab option. We'll just click OK and then OK, and this is your result. The mean is 148.50. We have already stated, we have already checked this in our Excel also. The standard deviation is 26.25, variance is 689, median is 145. Sir has already discussed in the last session that only one click is required to calculate this. I'm just showing you the practical part of that, whatever has been discussed. So this is the next software, which is Minitab. We'll use these software for inferential statistics as well. For hypothesis testing, for Z statistics, for T statistics, we'll use Minitab software as well. Now, coming to the next software, which is SPSS. This is more advanced than Minitab. SPSS is the software which is its full form is statistical package for social sciences. So it is developed by IBM, and this is more advanced than Minitab and Excel. Basic statisticians, me being in a management stream, so we basically use SPSS for all our data analysis part, for our factor analysis, for our cluster analysis, for our conjoint analysis. We all use the SPSS software for calculating our statistics part. Now I'll show you how to calculate mean and descriptive statistics using SPSS. Till now we have computed Excel and we have completed the Minitab application. So this is the software which is known as SPSS, Statistical Package for Social Sciences. This is the basic interface of SPSS. You can see the data has been entered. The same data I have taken here, rainfall, and we'll try to calculate the descriptive statistics using SPSS. Now in this option, you have to select the analyze part. In analyze, you have to go to descriptive statistics. As you can see, there are multiple statistics option which you can compute using SPSS: correlation, regression, parametric test, factor analysis, cluster analysis, multiple things you can compute through SPSS. That is why it is known as more advanced option than Minitab. So here we'll focus on the descriptive statistics part. In the descriptive statistics, you will go for frequencies, and then you have to select the variable for which you want to calculate the descriptive statistics part. We'll enter the variable rainfall because we have to calculate it for rainfall. Then we'll select statistics. Here also, you can use here also you can use a number of things: mean, median, mode. You can use standard deviation, you can use variance, you can use range, you can go for quartiles, you can go for percentiles. Anything which you want to calculate in statistics, you can use it through SPSS. And then we'll continue, we'll use OK. Even if you want different bar graph charts, which is also like pie chart, um, histogram, all those things, you can use it through this option, charts, bar chart, pie chart, histogram, anything. It will provide you in a separate dialog box. Then we'll go for OK. This is the result of our statistics. We have already seen mean is 148.5, which we have already verified through Excel and Minitab earlier. So this is how basic calculation of mean, median, mode is done using Excel, Minitab, and SPSS. Apart from this, there are certain things like harmonic mean, geometric mean, which we have already, which sir has already discussed. So how to calculate those things, which we'll see here. We'll use Excel first for calculating the geometric mean, for calculating the harmonic mean. Simple function is used in Excel to calculate harmonic mean and geometric mean. Let me show you. This is a simple question for calculating geometric mean. This is the data. You don't have to do anything. You just have to simple enter an function geo mean. You have to use the data. You have to select the data, and then you will get the desired result, which is 106.98. We have already calculated this 106.98. We have already got this 106.9813. You can see we have used a simple formula geo mean. Similarly, for harmonic mean, we will use harm mean. So this is what, just I have to see some message. Please repeat data analysis part in Excel. Okay. The data analysis part, it is not by default added in your Excel. You have to add that data analysis tool pack, which is, you can see visible here. Data analysis, it is visible here. It is not by default added. You have to use it by add-on option in your Excel. You can use it by going to the options menu in the menu bar, and there you have to use you have to check the data analysis tool pack. And when you check that data analysis tool pack in that option, you will get data analysis in this data option here. When you'll select this data analysis tool pack, you can use descriptive statistics. You can use it to calculate the descriptive statistics part, as well as different statistical computations which you want to use for your research or for your data. You can calculate it from here. You can see there is ANOVA, there is there is one-way ANOVA, there is two-way ANOVA, there is correlation, covariance, there is F test, there is T test, there is Z test. You can use it for the data analysis part. But we have, as I have already told you, that we have a more advanced option of SPSS. So basically it is not used as much as we use SPSS, but for the sake of this class, because we have to calculate, we have to show how it is done using Excel, Minitab and SPSS. I'm showing it here. So this is what data analysis tool pack is. It is not by default added. You have to add it using the add-on option. Now I will go to chapter number next chapter, that is measures of dispersion, because I think I've made myself clear that mean, median, mode, how it is calculated using one click in Excel, Minitab and SPSS.
Hello?
What?
Hello, sir.
Yes.
Sir, please explain that how to add that data analytics tools in the Excel.
Okay.
I am unable to see the screen.
Yes, I'll show you the screen. Don't worry. Is my screen visible to all of you?
Yes, sir.
Okay, this is the blank Excel sheet I'm opening. When you'll open an Excel sheet, blank Excel sheet, you will get this option here. When you'll select this option, you will get add-ons. And here you have to select this analysis tool pack. When you select this analysis tool pack, I've already installed this in my system. That is why it is here. But if it is not installed in your system, you have to search for this option using here. Analysis tool pack and analysis tool pack VBA. You have to check both the options, and when you'll select OK, that data analysis tool pack will be visible in your data section, data analysis. You just have to use the add-on function to insert this option in Excel. Clear?
Yes, sir.
Okay.
So it should be go to file menu and then Excel options.
Yes. We have to go to the file menu. Then you have to select the options, and then there you have to search for the add-on, that is analysis tool pack and analysis tool pack VBA. And when you check those options, you will get the data analysis part in your data option. If you are using Excel 2010, it will come under tools option, I guess. I'm not sure because I'm using 2013, but if you're using lower version to Excel 2010, it will come under tools option. That you can check. It is very easy to add this data analysis option.
Hello, sir.
Yes.
Actually, I went to my Excel in add-ins. In add-ins, I need to go.
Yes.
Add-ins and manage in the bottom, direct called something called manage.
No, yes, you have to go to, there is an option known as, there must be an option for checking the analysis tool pack and analysis tool pack VBA.
Yeah, inactive add-ons. Yeah, analysis tool. Yeah.
Yes, you have to check both the option and then you will get this option. This you can do it. This is not a discussion. Okay. Now you'll see how to calculate the measure of dispersion part. The same thing is this is a basic example. Maximum, minimum, coefficient of range, all these things, they can be calculated using the same options which we have discussed. I'm using it again for the sake of this example. We have to go to the data option. We have to select for the data analysis part. And here we'll select for the descriptive statistics. When you select OK, is input the range, all those range where your data is, summary statistics. We'll go OK. Here you will get range is 650, minimum is 100, maximum is 750. Now, main thing in this chapter is the box and whiskers plot. How it is drawn, the box and whiskers plot, how it is drawn using Minitab. So that I'll show you here, because the descriptive statistics part is nothing. How to calculate it, mean, kurtosis, variance, standard deviation, all these things are done using data analysis part. And there I have already shown you in Minitab and SPSS that it is how it is done. So the main thing we are coming on is the box and whiskers plot, how to calculate box and whiskers plot, how to draw that box and whiskers plot using Minitab. Okay, I have taken a simple example which is given in the slides, which sir will share with your course coordinator. You will get that example in that slide. How to draw a box and whisker plot for this example using Minitab, I'll show you. So Minitab can be easily used for this construction. We just have to click for graph here. We'll get the graph option here. And here you have to select for the box plot. When you select for the box plot, you will get this option, simple with groups, multiple Y, simple with group. Here it is simple and one Y. We just have to click OK. You have to select for the variable which you want to use in the box and whiskers plot. For the variable you want to identify the outliers, you can use the box and whiskers plot. Sir has already discussed. So you'll just have to click OK, and it will draw the box and whiskers plot for you. As you can see in this example, that it exhibits a right skewed distribution. So this is how a box and whiskers plot is constructed using Minitab, and how it is done in SPSS. I'll show you there also. Both Minitab and SPSS software you can download for your statistics part. You can easily get on the internet. Yes, sir. Added data analysis tool done. This is the example we have taken for our box and viscous plot. This is the interface of the SPSS and how to construct a box and viscous plot for. See, you can use any of the software. I am just telling you here that SPSS is more advanced or Minitab is inferior. I'm not saying that, but for sake of convenience, SPSS has much more options as compared to Minitab. But they both provide accurate results. They don't give any they don't have any differences in their results, so you can use any of them for constructing box and viscous, for calculating descriptive statistics, for testing the hypothesis. You can use any of them. I've already told you how to use in Minitab. Now I'm showing you how to use it in SPSS. Here you have to use for you have to go to graph option, legacy dialog box. Here you will get the option box plot. When you select the box plot, you will get the option simple or clustered. When you choose, you here will use the simple option and summaries for separate variables, and then we'll select define option. When you select the define option, it will ask for the series. So the boxes represent series. This is how box and viscous plot is calculated using SPSS. Basic idea of box and viscous plot is it is used to identify the outliers in the data set. Somebody is asking, is SPSS open source? No, SPSS is not open source. SPSS is not, no, SPSS is not open source. So please, can you explain box plot one example? Box plot is nothing. Box plot is when you have a big data, there are, we need license. Yes, you need license to use it. Box plot is nothing but when we have when we had very large number of data, there are chances of outliers. So when we have to identify the outliers, we use the box and viscous plot. It is also used to determine the skewness of the distribution. That here you can see the example, it is a right skewed distribution. So it means that the outer data are more skewed to right hand side. That shows that is the overall concept of box and viscous plot. Basic thing is we determine the outliers in the data set. When the data size is too big, there we have to find the outliers so that we can minimize those outliers, so that we can reduce those outliers. That's why box and viscous plot is used. Next we'll see an example. Now we'll see a complete example of measures of dispersion. Uh, okay. using MS Excel, Minitab and SPSS for the computation of range interquartile. This is the data of Ambuja Cement, L&T, Madras Cement and ACC. On this data, you have to calculate range, interquartile range, standard deviation, variance, coefficient of variance. This is the sales data of these four companies, four companies, and you have to calculate this thing. We'll use a complete example how to use it, how to calculate these data using Excel, Minitab and SPSS. So I'll use Minitab for calculating this. You can check the data using SPSS and Excel also. So here I am using Minitab. We have filled the data in Minitab. Now you will use to calculate the range, interquartile range and all those things which have been asked. The same thing we'll use. We'll go to stats, basic statistics, display descriptive statistics. We'll get the options like in the previous example. In that simple example, there was only one variable, that is rainfall. So we used only one variable. Now here we have four different options because we have the sales data of four different companies. So here we will use these four variables: Ambuja, L&T, Madras Cement and ACC. And then we'll select for the statistics part whatever thing has been asked. In this question we have been asked about the standard deviation, we have been asked about the variance, we have been asked about the coefficient of variance, we have been asked about the interquartile range. We'll select these options, and after that we'll click OK, and then we will get our desired result. Okay. As you can see, the descriptive statistics for our question. What can you observe from this result? Anybody? The basic thing is the coefficient of variation. If you can see that the distribution with the lesser coefficient of variation, it shows much consistency and much uniformity. Whereas when the distribution has a high coefficient of variation, it is considered more variable than others. So in this example, which you can see from the output, we can conclude that variation of ACC, this ACC cement has the lowest variation among all the companies. Hence, from this output, we can infer that in terms of sales, ACC is more consistent than other companies. The coefficient of variation of Ambuja cement is high. It means the Ambuja cement sales is more varied. Sir has already discussed about the standard deviation in the last class. Standard deviation shows the scatteredness of the data, how the data is scattered from the mean. So here in this example, we can conclude from the coefficient of variation that the sales of ACC is much more uniform, whereas it is more consistent among all the companies. Whereas Ambuja cement, it has high coefficient of variation, which from which we can conclude that this sales is more varied. So this is how a complete example is solved using Minitab. The same output we will get in SPSS as well if we will enter the data. Now we will go to inferential statistics and we'll see how inferential statistics is calculated using Minitab, SPSS, and Excel. Okay. This is the question which sir has asked me to take. Okay. A marketing research firm conducted a survey 10 years ago and found that the average household income of a particular geographic region is rupees 10,000. Mr. Gupta, who has recently joined the firm as a vice president, has expressed doubts about the accuracy of the data. For verifying the data, the firm has decided to take a random sample of 200 households. Sir has already discussed in the last session that in inferential statistics, we infer about the population using a small sample. Here, we will use a sample of 200 to infer about the population. Random sample of 200 household that yields a sample mean of rupees 11,000. Assume that the population standard deviation of the household income is rupees 1200. Let alpha is equals to 0.05. Alpha is level of significance. In the last session, sir has already discussed about level of significance. Level of significance is the chance of committing the mistake. Here we are taking alpha as 5%. You can take alpha as 10% and 1% and 5% as well. Mathematically, you can take any number as alpha. You can take 13%, 12%, 11%, but statistically, in globally, only 3 levels of alpha are taken, that is 5%, 1%, and 10%. For hypothesis testing, here in this question, we are taking 5% as the level of significance. How to compute it using Minitab? I'll show you. Okay. So in this question, which we have already read, we have, as sir has discussed, we first have to address the null and alternative hypothesis. So in this question which we took, the null hypothesis is mu is equals to 10,000, means the average household income has not changed, it is 10,000. And our alternative hypothesis is that mu is not equal to 10,000. Alternative hypothesis is opposite of null hypothesis. Here, the sample size is more than 30. That is why we are using Z statistics. So how to use it? We'll go to, this is a mini tab interface. We'll go to basic statistics, one sample Z test. Here, the sample size will mention sample mean 11,000. Standard deviation, it is already given 1,200. Hypothesized mean is 10,000. We have to check whether the household income is, the average household income is 10,000 or it has been changed. So we'll use Z statistics. There is an option of Z statistics and T statistics. T statistics is used when your sample size is less than 30, whereas Z statistics is used when the sample size is more than 30. Here, the sample size is more than 30, that is 200. That is why we are using Z statistics. We have input the data. Then we'll go to options, confidence level. Now, if the level of significance is 5%, means our probability of probability of a mistake is 5%, then the confidence level is 95%. If we will take alpha as 1%, confidence interval would be 99%. On the other hand, if we'll take alpha as 10%, our confidence interval would be 90%. So this you have to select. In this question, the level of significance is already known, that is 5%. That is why we are taking, yes, Z statistics depend on sample size. If your sample size is more than 30, we use Z statistics, and if the sample size is less than 30, we use the T statistics. Similarly, we have to use the confidence level 95%, already given in the question, and then we'll go to OK, and this will provide us the results. Now, what you can infer from this thing? Z value is 11.79. We check the critical value of Z from the normal table. For the 95% confidence interval, the Z value for two-tail distribution is 1.96. Here, the Z value is 11.79. So based on this, the Z value is greater than 1.96. It falls on the region where we have to reject the null hypothesis. It falls on the shaded area of the normal distribution curve. It will not fall in the middle part where we accept the null hypothesis. The value will fall on the shaded part of the normal distribution, in which we reject the null hypothesis and we accept the alternative hypothesis. This shows that the average household income of a particular region is not rupees 10,000. We have stated our null hypothesis as the average income of the household is 10,000, but the Z value, which is 11.79, it is greater than the critical value, which is 1.96, which we derive from the normal table. From that, we can conclude that we accept our alternative hypothesis, that is the average household income is not rupees 10,000. Now there is a concept of p-value. Apart from Z value, you can also calculate, you can also infer whether you have to accept null hypothesis or alternative hypothesis using here. The level of significance is 0.05 and our p-value is 0.000. It means our p-value is less than level of significance. When the p-value is less than the level of significance, we accept our alternative hypothesis. On the other hand, when the p-value is greater than the level of significance, we accept the null hypothesis. It falls on the acceptance region. We'll see one more example that will make more clear how to infer the null hypothesis and alternative hypothesis using p-value. So this is one question: how to calculate, how to test the hypothesis using Z statistics. We'll take one more example. We'll take this example. A cable TV network company wants to provide modern facilities to its consumer. The company has 5-year-old data which reveals that the average household income is rupees 1,20,000. Company officials believe that due to the fast development in the region, the average household income might have increased. The company takes a random sample of 40 households to verify this assumption. From the sample, the average income of the household is calculated as 1,25,000. The standard population standard deviation is 1200. Use alpha 0.05. Again, we have to use 95% confidence interval, and we have to check whether the average household income is 1,20,000 or not. So we'll use again Minitab for this. We will go to stat option, basic statistics. Again, one sample Z test. Sample size is 40. Sample mean is 1,25,000. Standard deviation is already given, 1200. Hypothesized mean, we have to check whether the average household income is 1,20,000 or not. Here the null hypothesis is mu is equals to 1,20,000, and the alternative hypothesis is mu is not equal to 1,20,000. We'll go to options. Again, we have to use 95% confidence interval, and alternative hypothesis, we have to set that mean is not equal to hypothesized mean, which is 1,20,000. And then we'll select OK. And we'll get this desired result. Now you can see that Z value is 26.35. It means here also we will accept the alternative hypothesis and we will reject the null hypothesis, as it is more than the critical value of Z, which we can derive it from the normal table. In general, if you'll imagine a normal distribution curve here, this value will lie on the shaded area of the normal distribution curve, which sir has shown you in the last class. This value will lie on that part, which shows the rejection of null hypothesis and acceptance of alternative hypothesis. Again, we have a p-value approach here. Here also the p-value is 0.000, which is less than the level of significance which we have taken as 0.05, which concludes that in this question also we will accept the alternative hypothesis, that is the average income of the households have been changed, and it is not 1,20,000. So these this is how we calculate the one sample Z test using Minitab. Again, we'll see one question. Now we'll see a question based on T statistics. We have already, how we understand whether income is increased or decreased. We have already set our hypothesis in the given question, as the null hypothesis was the income has not been increased, whereas the alternative hypothesis was the income has been changed. Now it is a two-tailed test. It is a two-tailed test. It can go to if we'll set a alternative hypothesis as the income has increased, we use a one-tail test. Similarly, if we will use that income has been changed, it could have been increased or it could have been decreased. For that, we use the two-tail test. Here we have used two-tail test. That's why based on two-tail test, we have tested our hypothesis. That was the income has been changed. Now we'll take a question on T test, T statistics. So this is a question on T statistics. I already told you the difference. When the sample size is less than 30, we use T statistics. When the sample size is more than 30, we use Z statistics. Here you can see the sample of the sample tires is 8, which is less than 30. That is why we use T statistics in this question. The question is, Royal Tires has launched a new brand of tires for tractors and claims that under normal circumstances, the average life of the tire is 40,000 kilometers. A retailer wants to test this claim and has taken a random sample of 8 tires. He tests the life of the tires under normal circumstances. Now we'll use this question using Minitab, how to calculate, how to test this thing in Minitab. Now, this is the Minitab interface. We'll use that same question for our how to calculate the T statistics. We'll go to stats option, basic statistics. One sample t-test. We'll insert the sample size as 8. The sample mean of the data was 39,750. Standard deviation was given. The hypothesized mean was 40,000. We'll choose the confidence level as 95%. And then we'll select OK. This will give you the desired result. Here you can see the concept of p-value. The t-value is 0.27 and p-value is 0.795. In this question also, we can infer about the null hypothesis and alternative hypothesis about from the p-value approach. The level of significance for this question was 0.05, 0.05, and please share the window of Minitab. It is not, the output box is not visible. Okay. Wait. Now is it visible? My end, no sir, not visible. Okay. Stop share. Now the screen is visible. Now visible. Okay. Now, here you can see the p-value is 0.795. P-value 0.795. It means it is more than the level of significance which we have decided. In our case, in this question, the level of significance was decided was 5%. 95% was the confidence interval and 5% was the level of significance. See, whenever we test the hypothesis, now the most easy approach is p-value approach. You just have to simply compare the p-value which you will derive from this software, and then you have to compare it with the level of significance which you have opted. In this case, 0.795, it is more than the level of significance, which is 0.05. Hence, we can say that in this case, we will accept our null hypothesis. The null hypothesis was that the average life of tires was 40,000 kilometers. So in this case, we'll accept the null hypothesis. It means the value will lie in the acceptance region of the normal distribution curve. So this is the beauty of the p-value, that you don't have to you don't have to see the normal table. You don't have to compare the critical value. You don't have to calculate the z value or t value, and you have to calculate it. You have to compare it with the t distribution or normal distribution. You just have to check the p value. You just have to analyze the value of the p, and you have to compare it with the level of significance, and you will answer your question whether the null hypothesis has been accepted or the alternative hypothesis has been accepted. If the p value is less than the level of significance, I repeat, if the p value is less than the level of significance, we accept our alternative hypothesis. On the other hand, if p value is greater than the level of significance, we accept our null hypothesis. Like in the previous two cases which we have seen, the p value was 0.000, and in this case the p value is in this case the p value is 0.795, which is greater than the level of significance. That is why we accept the null hypothesis in this case. So this is the beauty of p value. This is the beauty of Minitab. You just on a single click you can derive your answer. We'll see one more example. It is 10.5. The question is, The production manager of a company that manufactures electric heaters believes that at least 10% of the heaters are defective. For testing his belief, he takes a random sample of 100 heaters and finds that 12 heaters are defective. He takes the level of significance as 5%. Again, here the alpha is 5%. I'm repeating it again. Globally, we use 1%, 5%, and 10% as level of significance. Mathematically, you can use any number as level of significance, but statistically, statisticians across the globe, they use only 1%, 5%, and 10% as the level of significance. Applying the 7 steps of hypothesis testing, test his belief. So we'll use, we'll first set our null and alternative hypothesis in this case. So the null hypothesis in this case that 10% of the at least 10% of the heaters are defective. So null hypothesis would be mu is equals to probability is equals to 0.10, and alternative hypothesis would be that it is not equal to 0.10, and the level of significance is given as 0.05. Now we'll check using the Minitab option. Is the Minitab dialog box is visible to everyone? We'll go to basic statistics function, one proportion, and then we'll summarize the number of events. Number of events in this case, as you can see, is 12. Number of trials is number of trials is 0. Number of trials is 100, and we have already set our null hypothesis as mu is equals to 0.10. So we'll take the hypothesized proportion as 0.10. We'll go to options, confidence level, again 95%. It is given in the question. If in case nothing is mentioned about the level of significance, we generally take 95% only. So this is not the case. Alternative hypothesis, which we have already set, that it is not equal to 0.10. We will use the normal approximation method, and then we'll select OK. It will give you the desired result here. You can see again the observed value of Z, that is 0.67. It falls in the acceptance region. So based on this, you can see that the null hypothesis has been accepted. Now, when we'll compare it, if we don't know the Z, the critical value of Z from the normal distribution table, so how we will compare the Z value? But if we know about the p-value approach, here the p-value is 0.5. We can compare it with the level of significance. 0.5 is greater than 0.05. So from this we can infer that our null hypothesis has been accepted and alternative hypothesis has been rejected. So based on that, we can confer that at least 10% of the products, 10% of the electric bulbs which that manager was claiming are defective seems to be valid only. So the alternative hypothesis which we have set was 10% of the bulb was not defective. So the claim of manager from in this question seems to be true based on our calculation, based on our testing of hypothesis using p-value approach as well as the Z value approach. Now we'll see this was hypothesis testing for single population. Now we'll check the hypothesis testing for two populations. When we have two population, how to check for the hypothesis, and then we have three population. For that we use ANOVA and a number of things. So inferential statistics is not only subject to one population. It takes into one population, two population, three population, and further. So because of the time constraints, we are focusing on one population and two population. So now we'll switch to two populations. How to check the hypothesis testing for two population when we have the two population data. Yes. This is the question. Anmol Constructions is a leading company in the construction sector in India. It wants to construct flats in Raipur and Dehradun, the capital of the newly formed states of Chhattisgarh and Uttarakhand. Here we can see that we have two population. The company wants to estimate the amount that customers are willing to spend on purchasing a flat in the two cities. It randomly selected 25 potential customers from Raipur and 27 customers from Dehradun and posed the question, how much are you willing to spend on a flat? The data is available. The company assumes that the intention to purchase of the customers is normally distributed with equal variance in the two cities taken for the study. We'll use 95% as our confidence interval. Now you can first see the data. This is the data which is presented. Now the hypothesis is that mu1 and mu2, that is Raipur and Dehradun, the flats are, the rates are equal, that is mu1 and mu2 are equal, and the alternative hypothesis, that is h1, mu1 and mu2 are not equal. So this is what the manual calculation looks like of a t distribution. This is the method for the t distribution, but we will not use the manual calculation. Rather, we'll check for our we'll check for our Minitab output. So we'll open the Minitab output. Now, this is the data which this is the data which is filled in the Minitab. Then we'll go to stat options, again basic statistics. The sample size in this question is 25 and 27. It is less than 30. That is why we are using two sample t-test. So sample 1 is Raipur, sample 2 is Dehradun. We'll go in the options menu. Confidence level has been set as 95. Hypothesized difference, there is no difference in Raipur and Dehradun. Whereas alternative hypothesis, we have set our alternative hypothesis as that there is a considerable amount of difference in Raipur and Dehradun. So the question has stated that we have to assume the equal variances. Then we'll select OK. Somebody was asking about the graphs. So we can also plot the visual graphs in the Minitab option. So we can construct a box plot and individual value plot here. Now, you can see the descriptive statistics has been mentioned here. Mean is 143. Dehradun, the mean is 162. Standard deviation is 16.5. The data for Raipur is 14 point. The standard deviation for Raipur is 14.3. Now, our main concern here is p-value. The p-value here is 0.000. Again, we will compare it we'll compare it with the level of significance. The level of significance in this question was also 95%. So based on that, we will confer that our alternative hypothesis has been accepted and null hypothesis has been rejected. Alternative hypothesis was that there is no difference in the Raipur and Dehradun, and we are 95% confident that there is no difference in the cost of flats in Raipur and Dehradun, because it was our alternative hypothesis. The null hypothesis in this question was, you can see that there is no, the alternative hypothesis was that there is a difference, whereas the null hypothesis was that there is no difference in the the cost of flats in Raipur and Dehradun. So this is how we will test the hypothesis for two population. Now we'll see one more example for two population, and then we'll wind up this session. Okay, this is the question. An electronic goods company arranged a special training program for one segment of its employees. The company wants to measure the change in the attitude of its employee after the training. Here we have to measure the difference before training and after training. For this purpose, it has used a well-designed questionnaire which consists of 10 questions on a 1 to 5 rating scale. 1 here denotes strongly disagree and 5 here denotes strongly agree. Now it is a Likert scale question. So this is a different thing. The company selected a random sample of 10 employees. The scores obtained by this are presented here. You can see again, the null hypothesis is there is no difference in the before training and after training session, whereas the alternative hypothesis states that there is a considerable amount of difference in before session and after session. So we'll move on to our mini tab for testing this. So the data has been fed before training and after training. Basic, we have to compare basic statistics. Paired t-test because it is dependent. The variable is dependent on before training and after training. Yes. Sample 1 is before training. Sample 2 is after training. Again, options. Confidence level in this question. Just see, the confidence level for this question is 90%. Now we are not taking 95% as our confidence level. So the level of alpha will also change. Now the level of alpha will not be 5%. It will be 10% because the confidence level has been 90%. We'll select OK. And then this is our result. Again, we can see that the observed t-value is minus 4.13, which is less than our tabular value of t, which if you will see the tabular t-value for this 90%, you will get the tabular t-value as minus 1.833. and our t value is minus 4.13. So that implies the null hypothesis has been rejected and alternative hypothesis is accepted. So that is the case of t value, which you will compare it from the table. But we have a simple approach of p value. Here the p value is 0.003. The level of significance in this case was not 0.005, it was 5%. So based on this also, we can confer that null hypothesis has been rejected and alternative hypothesis has been accepted, because the p value is less than our level of significance, that is 10%. So this was the basic understanding of hypothesis testing. This was the basic understanding of Minitab, SPSS, and Excel. Basic hypothesis testing, you can do it in Minitab, and for the SPSS part, the same thing has been done. You can, let me show you the SPSS part as well. This is an SPSS interface. If you just select the example. Just I'll show you the SPSS output for this question also as well. So this is the SPSS output. This is the output which you will get from the when you will use the hypothesis testing for two population for SPSS. Here also you can see the p value is 0.003, which is less than the uh, level of significance. The t value here is 4.129. DF, that is degree of freedom, is 9. This is the basic statistics, mean and standard deviation. So this is how it is done in basic. We can use, it is not visible. This is the output of SPSS. This is the output of SPSS for hypothesis testing. This is the p-value. In the Minitab option, it is shown as p-value. Here it is shown as significance two-tailed, because it is a two-tailed test. So the p-value is 0.003. The degree of freedom is 9. The t-value is minus 4.129, which is less than our tabular value, which is, if you will see the tabular value from the table, it is minus 1.833. So based on this, we can conclude that a null hypothesis is rejected and the alternative hypothesis is accepted. So based on this, we can conclude that there is a significant difference in the attitude of employees before and after training, because our alternative hypothesis was that only that there is a difference. So this is how we use these different softwares for our descriptive statistics and inferential statistics. Just one click and number of data. If your data is too big, even that one single click is required to calculate anything you want in statistics. So I hope this is clear. So now I conclude my session. If you have any doubt pertaining to this, you can ask. let me see what is meant by normally distributed. No, the data which is what do you mean by normally distributed? That the data is normal distribution, not it is not inversely distributed, or it is a bell-shaped distribution. Majority of the value, it lies near the mean. That is what it is meant to be as normally distributed. When you will plot that data, it will form a bell-shaped curve. That is what it is known as normally distributed, normal distribution. How about multiple population, sir? For multiple population, we have to use ANOVA, that is analysis of variance. Analysis of variance is used when we have more than two population. Then, and there comes one factor ANOVA, two factor ANOVA, and there comes the interaction effect of row and column. When there is one data, one population, we have row. When there is two population, we have row and column. When there is a interaction effect in that, we use row and column interaction effect. So for more than two population, we use ANOVA. Sir, this SPSS tool is also used for predictive machine learning. Yeah, I don't have any idea of machine learning. So this tool is basically used for statistics part. That is for calculating all the statistics part. So if you have if you can use it for machine learning, I don't have much idea because I'm from a management stream, so I don't use machine learning. How about can you take one example? No, because the time has been limited. And but if you want to search for multiple population, you can read about ANOVA. You will get a plenty of idea about multiple population. So any more questions? Okay. Okay. Thank you. So